Well, hello and welcome back. I am Ruben Gamboa and I'm representing Team Game Programming. And we're going to talk about visualization basics and game programming using Snap. So we're changing programming languages. We're trying something different. Now, before we get into this, I have to apologize because I was not able to get things done before spring break started. So I'm not taping this from my usual studio. Things are going to be a little different. I'm using different equipment. I'm using my laptop. I'm not using my desktop. The truth is, I am hanging out at Cocoa Beach. So yeah, I know it's a rough life, but somebody has to do it. So this will be a little less formal than my usual stuff. And let's be honest, I'm usually pretty informal. So bear with me. I think it's still going to be fun. Um, what is Snap? So Snap is a programming language that is visual. Okay. Well, what that means is that you use a modern user interface that allows you to click and drag and drop to build your program. Your program ends up being something that you build by dragging programming elements as opposed to something that you build by typing programming statements. And what's nice about that is that there is no way for you to make a syntax error. You simply cannot mess it up. Um, if two things don't go together, like for example, if you're trying to put a for loop in a place that expects a condition, you can't. It will not let you. If you're trying to add a date and a string, it will not let you, and so on. The only things that it lets you do are things that make sense, and that means that you can stop worrying about whether you have a missing semicolon someplace or whether you're structuring your program correctly, and instead focus on what you're trying to accomplish. Okay, so it's a great language for learning, and its roots go back to, well, to be honest, its roots come back in two directions, but the most obvious dependency is Scratch. Okay, Scratch is a language that has the graphical component, is the drag and drop way of building programs, and it's been used successfully to teach kids how to program for a long period of time. I mean, lots of people use it. It's fantastic programming language. Unfortunately, it had some serious limitations that basically kept it from being a grown-up programming language. It was strictly for kids, and if you dig far enough, it was really intended to build animations. So it has all the features you need to do animations, and that's it. In that sense, it's similar, for example, to Agent Sheets that has all the stuff you need to do a certain kind of game and a certain kind of simulation, and that's it. So if you want to go beyond that, you're out of luck. That's the way Scratch was. Snap took that same user interface and said, let's make this a general programming language, something that you can use to build any program that you may want to, especially at the early college level. So if you take only one programming course in college, it could be with Snap. If you're a computer science major and you're starting to learn how to program, you can do it with Snap. Okay, and that's what they do at Berkeley for both of those purposes. So it works very well. And by the way, we're going to be doing that at the University of Wyoming as well next year, not for the computer science majors, but for incoming freshmen, just an introduction to programming. Now, Snap created a lot of ideas to make this happen, and many of those have been backported to Scratch, so that what I'm saying about Snap actually applies to Scratch as well. It's grown up, okay? So yeah, that kind of makes it interesting to choose. Should I use Snap? Should I use Scratch? Which one should I go with? My preference and what I'm going to do in this class is Snap, and simply because even today there are some things that it does technically a little better than Scratch does, just because of the history of where it comes from. That's kind of the hidden second part that I was alluding to earlier. Snap has kind of characteristics of two different programming languages. Scratch is the one you see, but the one that you really feel underneath it is actually something called Scheme, which is a functional programming language, which is general purpose. So actually, Scratch is still clings to its roots a little bit. Okay, Snap has flown a little farther than Scratch has. So yeah, they're both just fine for the K14 program. I personally like Snap better, so that's what I will be showing you, although everything really applies to Scratch as well. So if you want to, you can use Scratch instead. Here's the way that I would make that decision if I were you. Number one, Snap requires absolutely no installation. Okay, so if you have a web browser, you can run Snap. You simply have to go to a URL and boom, there it is. That's it. Okay, that is it. Um, if you run Snap that way, then you might be worried about what happens to my files. I mean, how can I save my program so other people can look at it? And actually, you shouldn't worry. Snap allows you to save your files on your local computer. It also allows you to save your files on the cloud if you want to. That means that they're hosted in some server at Berkeley. Both of those methods work as long as the security settings are just right. I have seen people run into problems because the system administrators at the schools tie down the network in such a way that you cannot, for example, use the cloud feature of Snap. If you run into those kinds of issues and you discover that actually Snap is not viable for you, then just use Scratch and don't worry about it. Okay. On the other hand, if you have a choice, if both of them work, then I go with Snap. If nothing else, you don't have to install anything. It just runs on your computer, assuming it works. On the other hand, with Scratch, you would actually have to download Scratch and install it first. Again, that can be problematic in school computers. So, you know, that's the way I look at it. If I have a choice, I'll go with Snap. Okay, so let me teach you the programming model in Snap. That is to say, what does a program in Snap look like? Okay, and what I want to say is that the model of programming in Snap is conventional. Okay, this is a good thing because what you learn when you're programming in Snap actually transfers very very nicely to any other programming language. Okay, or at least to the traditional programming languages, which is what your students are likely to grow up to start using if they continue on this path. So here's what Snap has. Snap has sprites. These are graphical, I almost want to call them agents, really, but these are just graphical little things that live on a stage, okay? One big difference is that the sprites can be of any size. Um, they don't, you can have big sprites, little sprites, whatever you need. Also, the sprites are really the things that have behavior, okay? There is also the stage. The stage can have a background that has pictures and so on. It doesn't necessarily have behavior. It's really at the sprite level. Okay, now each sprite can have one graphical depiction, which is what it looks like. It can also have more than one graphical depiction. They're called costumes. Okay, and the costumes can change. So you have a sprite that decides, oh, I want to have this costume now, and it just changes. That's just a different image that's stored with the sprite. Okay, and of course the sprite has code, and the code allows it to interact with the user. When the user clicks this, I will respond in the following way. That might be what a sprite says. The sprite can also interact with other sprites. Oh, when I see this other sprite next to me, this is what I'm going to do. The code for each sprite is entirely conventional. Okay, so sprites can have variables. They can have sequential statements such as set the variable x to 3 and then, that's the sequential part, and then I want you to do set the variable y to whatever y has currently plus x, and then, and so on, right? So those are just sequential statements. It can have if statements. If the variable x is less than 10, do this, otherwise do that. It can have loops. Keep doing this until x is greater than 100. You can have function calls and function definitions. What that means is that, for example, you can teach a sprite to run away. And then you can tell, hey, sprite, run away, and it will do whatever you taught it. Okay, those are the kinds of things that we do in many programming languages. For example, C#, Java, Python, Ruby, Perl, all, JavaScript, all these languages that people may want to program in after they learn how to program use the same type of programming. So if you learn it with Snap, it's very easy to transfer to those. And I think that is a huge benefit for your students. Now, I have to say, okay, so why are we doing this, right? Because, yeah, we're teaching them Snap, and we're saying it's really cool because then they can graduate to Python. Well, why not Python anyway? I mean, what's the difference? Here's one huge difference that Snap and Scratch has that all those other languages do not have, and that is that the code is graphical. So you actually construct it by dragging and dropping elements, And in other languages, what you'd be doing is going into an editor and typing those statements. Whereas in Snap and Scratch, you're dragging blocks and composing by putting one block on top of another, putting one block inside another, and so on. So you might be thinking the same way that you think in C Sharp or Python or Java, but you're constructing the code in a much easier way. That way you can learn the computational thinking and you're never really stuck with, oh my God, I missed the parentheses and that set me back for 15 or 20 minutes because I couldn't find a place that the parentheses was missing. You know, a comma, I had two commas instead of one comma, and that's why nothing worked for 30 minutes. Those are the kinds of issues that can really frustrate beginning programmers. Let's be honest, they frustrate professional programmers as well. The difference is that professional programmers understand that and they go, yep, that's what, I chose this job, I chose to deal with computers, I'm paying the price now, right? But beginners, they run into that and they say, oh, I hate computers, I never want to do this in my life. And it's simply because they haven't gotten past that point where they understand that what the computer is telling them is an error. It's probably something very trivial and you just have to go look for it. It's not something deep that there's a real problem with your program. It's just something simple. Um, so that's why we do it as opposed to Python. Okay, the fact that you can focus on your program, the actual computational aspects, as opposed to the syntax aspects, semicolons, parentheses, and so on. That's what makes it really, really cool. Okay. All right. So this is what it looks like, and what we have here, this is how you program. So, for example, here are blocks that I can just drag and put them in this area. This is the script. This is where the program would go. Here is a sprite. It looks like an arrowhead. I can ask it to move. I can ask it to set the pen color to, looks like maroon there. That's my favorite color. All sorts of things that I can ask it to do, and then it will actually run right here. This is the stage. Okay, so we have here the commands. We have the stage. We have here where the program will go. And this is where the sprites, this has basically a little icon for each one of the sprites. I have only one of them right now, which is the arrowhead. But if I create more, and here are the buttons to create more, then they will just show up here. And when clicking on them, I have the program for that particular sprite. Now, this is a nice picture and all, but the only way to really learn how to do this is to actually play with it. So what I'm going to do is I'm going to show you some things in Snap by bringing up the website and showing you some things that I can do. Okay. Later, I'm going to give you the assignment, and the assignment is for you to do precisely that. So I'm going to show you some Snap features in the next video. I'll see you in a second.